The topic which I am going to discuss today is cumulative atmospheric hazards, that is landslide and floods. Introduction. Cumulative atmospheric hazards are those events which are caused due to cumulative effects of weather events which prolong for longer period of time, ranging from a few weeks to several years, depending upon the nature of weather events. The cumulative atmospheric hazards which we will discuss today are floods and landslide. Floods simply mean inundation of extensive land area with water for several days in continuation. Generally, floods are considered to be associated with rivers, and people conceive floods as the outcome of accumulation of huge volume of water coming out of rivers through overlapping of river banks during peak discharge period. Landslide, simply defined as the mass movement of rocks, debris or earth down a slope, and have come to include a broad range of motions whereby falling, sliding, and flowing under the influence of gravity dislodge earth material. They often take place in conjunction with earthquakes, floods, and volcanoes. The causes of flood. Since the flood of rivers are the response of both natural and anthropogenic factors, the causes of floods of the alluvial rivers come from place to place. The following causes may be held responsible for devastating flood of alluvial rivers. Point number 1. Heavy rainfall for long period in continuation is the root cause of river floods because immense volume of water, either through high intensity rainfall or large scale snow melt, is the prerequisite condition for river floods. Heavy rainfall in the upper catchment areas of the concerned river causes sudden increase in the volume of water downstream. Point number 2. Heavy spell of rainfall in arid and semi-arid where the rainfall is scant, low and infrequent causes flash flood because such areas have poor natural drainage system and existing rivers and streams are unable to accommodate enormous volume of water caused due to huge volume of runoff resulting from high intensity rainfall during occasional rainstorm. Point number 3. Highly strenuous and meandering courses of the rivers obstruct the normal discharge of water and thus the velocity is reduced, which delay the passage of water, resulting into stagnation of water. Consequently, the meandering valley are immediately overflow and meander belt and lobes are flooded. Point number 4. Large-scale deforestation in the upper catchment is perhaps the most important anthropogenic factor of the causes of the river floods. In the absence of forests and other vegetation covers, raindrops strike the ground surface directly, and in case of heavy downpour, the rainfall exceeds the limit of infiltration soon and the maximum runoff is generated, which reaches the rivers through rivulets and streams and causes flood. Point number 5. Increasing urbanization also helps in increasing the surface runoff and therefore dimension and magnitudes of floods because extension in the Pakka ground cover through the construction of building, courtyard, road, pavement, etc. Reduce infiltration of rainwater significantly and increase surface runoff considerably, which increased the volume and discharge of storm drains of urban areas. Types of flood. Point number 1. Snow-melt floods. Precipitation is the form of snow, does not produce runoff or infiltrate into the soil, but waits until the snow melts, which means the several months of precipitation can accumulate above the soil surface. Rain on the snowpack or water from the melting snow can be held within the pack until the high liquid water content finally causes the pack to collapse, releasing water catastrophically and cause the snowpack to melt while the underlying ground is still melt frozen, which prevents any infiltration. Because of these reasons, snow melt floods can be very large. Point number 2. Storm surge. Floods in coastal areas and in river estuaries are usually due to storm surge, which result from the sea being driven onto the land by meteorological forces. Here, two physical forces act together. A storm with intense low pressure causes the level of sea to rise because of barometric effects and strong winds associated with this storm, if directed on shore, drive the sea on the land. Storm surges are thus commonly associated with tropical cyclones. Point number 3. Flash flood. Flash floods are defined as floods of short duration with a relatively high peak discharge. They arise from local precipitation of extremely high intensity, typical of thunderstorm. The high concentration of rainfall on a small area can have devastating effects as the river flow can rise to several hundred times the normal flow in the space of a few hours. They arise from local precipitation of extremely high intensity, typical of thunderstorms. The high concentration of rainfall on a small area can have devastating effects as the river flow can rise to several hundred times the normal flow in the space of a few hours. Flood disaster management. The various measures adopted for flood mitigation may be categorized into two groups, that is, structural and non-structural. Number 1. Structural. The main thrust of the flood protection program undertaken in the country so far in the form of structural measures may be grouped into the following. Point number 1. Dams and reservoir. Point number 2. Embankment, flood walls, sea wall. Next point. Natural detention basin. Next. Channel improvement. Next. Drainage improvement. And lastly, diversion of flood waters. Next point. Non-structural measures. On the other hand, aim at modifying the susceptibility to flood damage as well as modifying the loss burden. The various non-structural measures being implemented in the country are: number A. Modifying the susceptibility to flood damage through, that are Flood plan management. Flood proofing including disaster preparedness and response planning and flood forecasting and warning. Number B, modifying the flood laws burden through that are disaster relief, flood fighting including public health measures. Now, let us discuss another cumulative atmospheric hazard, that is landslide. As mentioned earlier, landslides are simply defined as the mass movement of rocks, debris or earth down a slope. Prolonged rainfall causes heavy landslide which block the flow of rivers. Such formation of river blocks can cause havoc to the settlements downstream on east bustling. In the hilly terrain of India, including the Himalayas, landslides have been a major and widely spread natural disaster that often strike the life and property and occupy a positions of major concern. One of the worst tragedies took place at Malpa in Uttarakhand, UP on 11th and 17 August 1998 when nearly 380 people were killed when massive landslides washed away the entire village. Vulnerable regions of landslide in India. According to the studies carried out by the Central Road Research Institute, the two regions most vulnerable to landslide are point number 1, the Himalayas, and point number 2, the Western Ghats. The Himalayan mountains belt comprise a tectonically unstable younger geological formation subject to severe seismic activity. The Western Ghats are geologically stable but have uplifted plateau margins influenced by new tectonic activity. Thus, the two regions have different geological setting leading to characteristic type of landslide. Compared to the Western Ghat regions, the slides in the Himalayan regions are huge and massive, and in most cases the overburden along with the underlying lithology is displaced during sliding due to the seismic factor. Broadly, the country has been divided into the following regions in terms of incidence and severity of landslide. Incidence of landslide in India. Region. Incidence of landslide. Himalaya, high to very high. Northeastern hills, high. Western Ghats and the Nilgiris, moderate to high. Eastern Ghats, low. Vindhyachal, low. Landslide zonation mapping is a modern method to identify landslide-prone area and has been in use in India since 1980s. The major parameters that call for evaluation are as follows: slope magnitude, length and direction, soil thickness, relative relief, land use, drainage pattern and density, landslide affected population. Causes of landslide. Landslide can be caused by the following causes. Point number 1, ground causes, weak sensitivity or weather material, adverse ground structure, joint features, etc. Physical property, variation, permeability, plasticity. Point number 2, morphological causes, ground uplift, volcanic tectonic, erosion, wind, water, score, deposition, loading in the slope stress, vegetation removal by forest, fire, drought, etc. Point number 3, Physical causes: prolonged precipitation, rapid drawdown, earthquake, volcanic eruption, thawing, shrink and swell, artesian pressure. Point number 4. Man-made causes: excavation, particularly at the toe of slough, loading of slope trace, drawdown of reservoir, deforestation, irrigation, mining, artificial vibration, water impoundment and leakage from utilities. An overall evaluation of the landslide occurrence in the Kerala part of Western Ghats and its corresponding eastern flank falling within Tamil Nadu reveals the following main features. Almost all mass movement occur during monsoon, southwest and northeast monsoon in the western flank of Western Ghats and during occasional cyclonic events in the eastern flank, indicating that the main triggering mechanism is the oversaturation of overburden caused by heavy rains. There seems to be a relation between intensity of rainfall and slope failure. Majority of the catastrophic mass movements is confined to the overburden without affecting the underlying bedrock. Improper land use practices such as heavy tilling, agricultural practices, and settlement patterns have contributed to creep and withdrawal of due support in many cases. A common factor noticed in most of these vulnerable sloughs is deforestation in the recent past, cultivation of seasonal crops, and increase in settlements. In all the vulnerable slopes, terracing, contour bunding is adopted mainly to prevent soil erosion and to enhance percolation during dry seasonal crops. Invariably, in all these cases, natural drainage of excess storm water during high-intensity rains prevalent in this area. In some areas, developmental activities like construction of building, road cuttings, embankment, cut and fill structures cause modification of natural slopes, blocking of surface drainage, loading of critical slopes, and withdrawal of due support, promoting vulnerability of critical slopes. Mitigatory measures. In general, the chief mitigatory measures to be adopted for such areas are: number 1, drainage correction; number 2, proper land use measures; number 3, reforestation of the areas occupied by degraded vegetation. Point number 4, creation of awareness among local population. The most important triggering mechanism for mass movement is the water infiltrating into the overburden during heavy rains and consequent increase in pore pressure within the overburden. When this happens in steep slope, the safety factor of the slope material gets considerably reduced, causing it to move down. Hence, the natural way of preventing this situation is by reducing infiltration and allowing excess water to move down without hindrance. The universal use of contour bunding for all types of terrain without consideration of the slope, overburden, thickness, and texture or drainage setup needs to be controlled, especially in the plateau-edge regions. It is time to think about alternatives and innovation which are suitable for the terrain to be set up. Conclusion. From the above discussion, we can conclude that cumulative atmospheric hazards such as the flood and landslide are events which are caused due to cumulative effects of weather events. The flood hazard is compounded by the problems of sediment deposition, drainage congestion, and synchronization of river floods with sea tides in the coastal plains. Landslides occur as a result of changes on a slope, sudden or gradual, either in its composition, structure, hydrology, or vegetation. Although these hazards are the outcome of the destabilizing forces of nature, man-made changes to the Earth's surface also aggravates to this situation. Poor management of agricultural land, increased deforestation, and urbanization all alter the retention properties of surface soil layers, resulting in greater runoff and increased erosion. Some critical measures that could be undertaken to prevent these hazards are taking of drainage measures, erosion control measures such as grass plantation, retaining wall, and most importantly, preventing deforestation and improving afforestation.